In section 9.6, we're going to look at graphing inequalities. Notice, in order to graph an inequality, we first of all need to know what type of graph we're going to make. And that's going to be determined on whether or not you have a less than or greater than, or if you have a less than or equal to or a greater than or equal to. Now, if you have just a strictly less than or a strictly greater than, then we will have what is called a dotted or a dashed graph. Which means whenever we do draw our graph, it will be a dotted or dashed line. However, if we have a greater than or equal to or a less than or equal to, use that little line underneath the equal to remember that that means that our graph is going to be a solid graph, meaning it will not be dashed or dotted. It will just be a solid line. Now, also with inequalities, we usually have to shade a portion of our graph. In order to determine which part of the graph we're going to shade, either above or below, left or right, you choose any point that is not on your graph and test it. Plug it in. If that particular point works, then you shade that side of the graph that the point is on. If that point does not work, then you shade the side of the graph that that point is not on. So you can choose any point you want as long as this is not on the line. If it works, great, shade that side of the graph. If it doesn't work, then you shade the other side of the graph that that particular point is not on. And that's pretty much it, at least when we're just graphing one graph, which is how we will start here. For our first problem here, let's look at the graph y is greater than or equal to x plus 2. If you ignore the inequality here for a second, what we have is a line in the form y equals mx plus b, where our y-intercept is 2, and our slope, so our 2 here is the y-intercept, and our slope, which is kind of hidden, is out in front of the x, is a hidden 1, is going to help us graph our line. Notice though, because of the greater than or equal to, when we do graph our line, it will be a solid line. So remember, to graph lines, we start out by graphing the y-intercept, which is, in this case, 2. So we'll go up to 2 on the y-axis and plot our point. Then we'll use our slope, which is 1. So we'll rewrite that as 1 over 1, which means we have a rise over run, which means we'll go up 1 and right 1. So if we go up 1 and right 1 from our y-intercept, that blue point will be over here. Then we're just going to play connect the dots and draw our solid line through our points. And we've done half of the problem at this point. Now we just have to figure out which side of the graph to actually shade. So to figure out which side of the graph you're actually going to shade, you need to pick a point to test. Well, let's see. I'm going to pick the point 0, 0 because it's not on the line. See that 0, 0 is at the center of the graph? If 0, 0 does work, then we'll shade that side of the line. If not, we will shade the other side of the line. So how do we know if it works? We actually plug in the point. So we're going to plug in 0, 0, which means we're plugging in 0 for x and 0 for y. Well, then what that means is on the left-hand side of the inequality, we get 0 is greater than or equal to. Well, on the right side, we have 0 plus 2, which is 2. So the question is that a true statement? Is 0 greater than or equal to 2? And the answer is absolutely not. 0 is not greater than or equal to 2. So that means our point 0, 0, I'm going to put a little X on it, does not work. So that means we're actually going to shade the other side of the line that 0, 0 is not on. So that means I'm going to shade the upper portion, the other side of the line that 0, 0 is not on. And that is our final graph. For our next problem, same idea. We need to graph our function. Well, notice on this next one that we do have a strictly less than, which means when we do graph our line, it will be dotted, not solid. So, what kind of line is it? Well, notice because we've only got y's and no x's, it means actually we have a special kind of line. It's a horizontal line at y equals 3. So we'll have a horizontal line at y equals 3 here. Notice I'm drawing it as a dotted line. So the question becomes, which side of the dotted line are we going to shade? Well, again, if you're not sure, go ahead and test a point. We're going to test the point 0, 0 like always because it's not on the line and it's pretty easy to plug in and test. So we'll plug in 0, 0, which is a 0 for x. Well, there's nothing to plug in then. And a 0 for y. And so let's see what happens. That gives us the inequality 0 is less than 3. So is 0 less than 3? Absolutely. So that means that 0, 0, we're going to put a little check there, works this time. Because that does work, we're going to shade that side of our graph that 0, 0 is actually on this time. Because it worked. So I'm going to shade that entire side that 0, 0 is on. That's all. We're done. Let's look at the next